Good evening, everyone. Welcome to Biosafety Now's 12th Twitter Space. Biosafety Now is a US-based nonprofit organization we launched in February of this year. We're led by experts in biomedicine, mathematics, public health, public policy, law, social science, and public advocacy. And we're working for a future where scientific research on pathogens supports human life without threatening it, and public trust in science is restored. To learn more about our mission, you can visit our website at biosafetynow.org. I'd also like to encourage everyone to read the petition that we have posted on our Twitter account to prohibit dangerous gain-of-function research that creates enhanced potential pandemic pathogens. If you read it and agree with our position, I'd encourage you to add your signature. We've already collected more than 1,900 so far in the 18 days since we launched the petition. So we're collecting over 100 signatures per day, which I think was a very strong pace. I think the more people become aware of that petition, the more we'll sign and the more impact it can make. So please add your signature, add your voice, so we can try to end the madness, so to speak. So my name is Bryce Nichols. I'm a professor of genetics at Rutgers University and laboratory director at the Waxman Institute of Microbiology. I'm one of the co-founders of Biosafety Now. I'm joined tonight by another one of the Biosafety Now co-founders, Justin Kenny, who's a professor of quantitative biology at Cold Spring Harbor Laboratory, as well as our sort of special guest, although she's also a member of Biosafety Now's leadership team, Dr. Laura Kahn. She, for 20 years, worked as a research scholar with the program on science and global security at the Princeton School of Public International Affairs. She's written dozens of articles on biosafety, biosecurity, and biodefense, many of which have been published by the Bulletin of the Atomic Sciences. Most relevant to our discussion tonight, she's one of the co-founders of the One Health Initiative. It's an initiative that seeks to achieve optimal health outcomes by recognizing the connections between people, animals, plants, and the environment. And I believe, if she will allow me to say so, she's about to release her third book. Do you want to mention what the title of that book is?
Thanks, Bryce. Yeah, pleasure to be here. The tentative title that I gave it is One Health and the Politics of Coronaviruses, although I'm not sure that my publisher is going to use that, but that's the title that I would like.
Okay.
I'm waiting to get the galleys back from the publisher. The manuscript's with them now.
And when you do finally publish that, obviously we'd love to have you come back on a Twitter space and talk all about it.
Sure.
I would.
Yeah, I'd be happy to.
I would mention, I noticed that on your Wikipedia page, it says you are an expert in the field of zoonosis. And I thought that was
Right.
that was actually quite interesting, given all the discussion about whether COVID has emerged by lab accident or through zoonosis.
Well, regardless of, whether it was a lab accident or zoonosis, zoonotic spillover events happen all the time. So, whatever caused this pandemic doesn't negate the fact that we still have to deal with zoonotic events.
Right. No, I just thought it was interesting, given that you have so many, like, the expertise you have is quite substantial. Also, food safety and security, antimicrobial resistance. I wanted to, I guess, what we wanted to talk about tonight was the One Health initiative that you co-founded. So I thought, could you please sort of go back and explain how that began? What it is,
Sure.
and the history of how it was started.
Well, I just want to give a little background to that background. And, the term One Health is relatively new, but the concept that human health is linked with animal health, plant, and environments is actually quite ancient. For example, Hippocrates, the Greek physician, recognized that when people went to low-lying swampy areas, they would get sick. And it took a couple thousand years before research was done to discover that mosquitoes could spread malaria. And the term malaria literally means bad air. So people recognize that bad air, I mean, the whole miasma concept was, part of that. Bad air could make people sick. Um, and of course, many indigenous peoples would recognize that their environment was critical for their health and well-being. So, but more recently, the term zoonosis was coined by, and I'm going to screw up his name, Dr. Rudolf Virchow, a German physician and pathologist whose father happened to be a butcher. And he would take thin slices of meat and look at them under the microscope, and he discovered parasites in the meat. And if people ate those parasites, they would get sick. And the term trichinosis, particularly infected pork, was a serious problem. And so he tried to get the authorities to require meat inspection. And of course, the meat producers were dead set against it. But he persisted, and those requirements were implemented. And a number of years later, the US started requiring microscopic examination of meat to ensure that it was safe. So that's the very earliest example of food safety. More recently, as we've witnessed during the 20th century, increasing numbers of zoonotic diseases spilling over into human populations. And there have been many people working in this area. Jim Steele started veterinary public health at the CDC, and he's considered a giant. Lots of scientists working in the area, veterinarians. The term one medicine was coined by Dr. Calvin Schwab, who was a veterinary epidemiologist, who recognized that sick animals could make people sick. So he coined the term one medicine, and it was in 2007 that the AMA passed a resolution. They didn't like the term one medicine, they liked the term one health for political reasons. So they unanimously passed a One Health resolution. The AVMA subsequently followed suit. This resolution was to promote communication collaboration between the American Medical Association and the American Veterinary Medical Association. So One Health was kind of begun at that point. So it's been around for several decades, not that long, but again, the concept is really quite ancient. And I got involved in it when I started at Princeton. I was just about to start my master's in public policy program in the fall of 2001. That was the year of the 9/11 attacks, followed by the anthrax letters, the letters of which were mailed from a post box in downtown Princeton, which was shocking. That was an incredibly surreal event, watching all of these events unfold, and that changed the trajectory of my career. I went from hospital quality oversight to biodefense, and studied under Professor Frank von Hippel. He taught a class called Prevention Against Weapons of Mass Destruction, focusing on nuclear disarmament issues, and I wanted to focus on biodefense issues. And some people are just amazing human beings, and Frank von Hippel's one of those people. And I really wanted to work with him and with his group. He was just so inspiring, and so I was very lucky that he took me on, and I was with his group for almost 20 years. So that's kind of how I got into it.
But so the course was called Weapons of Mass Destruction, you said?
Prevention against weapons of mass destruction.
Okay. prevention against. Yeah, so
Yeah.
it's interesting, and that kind of ties into what the title of tonight's space.
Mm-hmm.
You're talking about One Health, yet
Right.
we're also now talking about weapons of mass destruction. Like you have a career that you've learned a lot. You've written a lot about biosafety, biosecurity, bio.
Right. So the overlap is that, and it came from me reading the veterinary medical literature. There were a couple of bellwether events. There was the 1999 West Nile virus outbreak in New York City. I'm not going to go into the details of that outbreak, but it was the first time that that virus appeared in the Western Hemisphere. And the person who cracked the case was Dr. Tracy McNamara, who was a veterinary pathologist at the Bronx Zoo. And nobody was going to listen to her because she was a veterinarian. And they said, the CDC wasn't interested in talking to her because she was a veterinarian. But yet she held the key. And so that just really struck me. And when I had gone to medical school, the term zoonotic disease was never mentioned. I mean, when we study microbes, infectious diseases, we don't look at well, at least when I studied it back in medical school, the ecology of these microbes really wasn't discussed. It was purely focusing on the disease, um, the disease, how it presents in the patient, and how to diagnose it. But you don't learn about the bigger picture of what how this person got exposed in the first place. You're just focused on treating it. So it's quite narrow-minded, I think, very reductionistic in its approach to health and disease. I've always been more interested in preventing disease than treating it. And to prevent these types of diseases, you really need to know the ecology of them and how they spread. Um,
So, Laura, I was going to go back to Tracy McNamara. So, how
yeah.
did eventually she convince them, that what she was saying was correct?
Right. So this is actually a great story because at that time, the working diagnosis was St. Louis encephalitis, which is a mosquito-borne virus. Um, and so when you look at let's talk about the birds, because it was the birds that were primarily affected. The birds that were native to North America should have been resistant to St. Louis encephalitis. I should back up and say a number of her birds were getting sick and dying. The birds that were getting sick and dying were the birds that were native to North America. Now, if the virus had indeed been St. Louis encephalitis, those birds should have been healthy. Uh, and the birds that were native to Europe and Africa should have been the ones getting sick and dying. But the exact opposite was happening. The birds that should have been resistant were getting sick and dying, and the birds that were supposed to be immune were and I think I'm screwing this up. Hold on a minute. The birds that were immune should have been healthy, and the birds that were not immune should have been getting sick and dying, but the exact opposite was happening. The birds that were native to North America were getting sick and dying, and the birds that were native to Europe and Africa were fine. So she knew it couldn't be St. Louis encephalitis because the susceptibility of the birds were telling her a different story. And she suspected that it was a new virus that the birds of North America had not been exposed to before. And the CDC said, we only care about human health. We don't care about your birds. So go talk to the folks at the Ag Lab in Ames, Iowa, and send your bird specimens there. So she decided, she had a colleague at USAMRIID, the U.S. Army Medical Research Institute for Infectious Diseases in Frederick, Maryland. And she sent her lab specimens to her colleague there. And there they determined that it was West Nile virus like until they were able to confirm that it was indeed West Nile virus. And that confirmed her suspicions. Dr. Ian Lipkin at UC Irvine also determined the same thing, so it was confirmed. So that was a huge bellwether event. But what that means, and what I read in the veterinary medical literature, is that the vast majority of agents of bioterrorism and the vast majority of emerging infectious diseases are zoonotic, meaning that they're diseases of animals that infect humans. And yet, when I was doing my policy research, surveying departments of health and agriculture and physicians and veterinarians, they never talked to each other. They never collaborated with each other. They really didn't interact with each other. And yet the microbes didn't necessarily see a difference between humans and the other animals. But we created these arbitrary divisions between them, much to our detriment. So I wrote up my findings in a paper in the CDC journal Emerging Infectious Diseases, saying that we really need to get the physicians and the veterinarians to talk with each other. I mean, we're dealing with zoonotic diseases here. And I got a huge response from the veterinary community, and I heard crickets from the physicians. They were not interested, they did not respond, nothing. So the concept of One Health has been largely driven by the veterinarians, medicine, much less so.
Well, it's actually, so I want to go back to something you said about when you entered medical school,
Yeah.
that the the focus was on treating people that had acquired the viruses, not figuring out where they emerged from. Did I hear you correct when you said that?
Well,
Or there was
the medical medicine does, and that's another long story. But medical education focuses on patient care. So you're focusing on the patient in front of you and diagnosing whatever they might have. You don't really ask them, well, you don't ask them usually, where do you think you got this from? Um, or you're not really focused on the ecology of how these microbes could have gotten into their body. You're
I
just
see.
solely
Okay.
focusing on treating them. You
I
see what I'm
guess,
saying?
yeah, okay. I guess I perhaps misunderstood a little bit because I wanted to, at some point, I guess really the question is, when did this go off the rails, in the sense where the focus on identifying origins of viruses and looking for
Right.
zoonosis has led to what is likely, resulting in the current pandemic, with
Right. Well,
respect to the.
there were two divorces occurring in the turn of the 20th century, early in the 20th century. One was the divorce between medicine and veterinary medicine that occurred right around the turn of the 20th century because they used to train together, and that became a divorce rather early on. And then there was the divorce between medicine and public health. All physicians used to be much more involved in public health, and there's a lengthy story about the divorce between them, medicine and public health. Uh, Medicine, split off, and public health became the Cinderella, forever underfunded and underappreciated, and all the funding went to tertiary care medicine. And there's a lengthy history on that, which I'm happy to discuss, but it's going a little bit into the weeds. So, so medicine became increasingly reductionistic in its approach to health and disease. Public health became an unfunded Cinderella, and veterinary medicine, went off its separate way. Increasingly focusing on dogs and cats. Fewer and fewer veterinarians are going into large animal medicine. There aren't that many jobs in wildlife medicine or zoo medicine, but the key areas, at least in terms of food safety, food security, is large animal medicine, and of course preventing spillover events. You want veterinarians in wildlife medicine, and there just aren't that many jobs.
Are you implying that again, because we keep hearing about all the funding that's going into the identification, well, the viral collection programs and studying viruses.
Right.
The implication, I know this is getting a little ahead of where we were before, but is the implication that there are extremely underfunded priorities that would really help prevent
Yeah.
zoonosis, that and then that's, I guess that's part of what you want to talk about with respect to restoring what really One Health means.
Right,
um,
right. So, look, some countries, they have, particularly in the developing world, they have very minimal public health, much less animal health. I mean, some countries don't have any veterinarians at all, which is, makes identifying sick animals much, much harder if you don't have the personnel to do it. I mean, you want to be, the physicians and the veterinarians are the eyes and ears of public health. And if you don't have the people who can identify sick animals or sick people, then you're going to be blind.
so Laura, going
Hmm.
back to the 2007, there's
Hmm.
the resolution that led to the One Health initiative, what was, I guess, then branded One Health.
Right.
What was your, well, I guess the one question
Hmm.
is, what exactly was your involvement in that resolution? Did you help draft it or implement it,
I
or?
drafted it. Dr. Ron Davis, who was then president of the AMA, asked me to draft that resolution, which I did with input from him, Dr. Roger Marr, who was then the president of the AVMA. I got input from other colleagues, and so it passed unanimously by the AMA. Unfortunately, I mean, Dr. Ron Davis was a real great advocate and one of the few physicians who really understood the importance of this concept. But tragically, about a year later, he developed pancreatic cancer and died. And we lost, I mean, his loss was tremendous because he would have helped to bring the the medical community along, and one of the reasons why it became largely driven by the veterinarians rather than jointly by both.
So when you say driven by the veterinarians, I'm a little confused by. So
Hmm.
you mean this is at post 2007 that they
Right.
they took it? Is it? I'm implying. I guess my understanding is they took that term and thought, okay, well, we can use this to get more funding.
Right.
Is that the idea?
Well, so
Um,
they developed a One Health task force, an AVMA task force,
okay.
that eventually evolved into the One Health Commission that was, for a couple of years, headed by Dr. Roger Marr, who was the former president of the AVMA. The One Health Commission is now headed by Dr. Cheryl Stroud, who's a veterinarian, and she's that organization is committed to education and outreach, and has a very useful website, the One Health Commission website. But the veterinarians are teaching One Health in their schools, and just a tremendous amount of interest. I mean, when you're dealing with any kind of One Health activity, it's primarily veterinarians or veterinary students. Getting the medical students engaged, there have been a few, but that's been more the exception than the rule, in comparison to the veterinarians.
So, Laura, just to go back, well, just to clarify, when you say a One Health activity, because going back
Hmm.
to the initial initiative, the resolution was
Right.
to promote communication. So, what exactly was? So, it was an advisement of how to do that, or were there actual specific recommendations of infrastructures or like?
Yeah, there was recommendations to have joint conferences, to have joint educational activities, joint research efforts. Um, Harder in the clinical setting because you really don't want to treat people and their animals at the same place. So that's not really going to happen. Although I must say that in parts of Africa, uh, I co-wrote an article with one African colleague who found that people were more willing to get their kids vaccinated if they vaccinated the livestock as well. The livestock vaccination was more valuable to the nomadic pastoralists than vaccinating their kids. So if you did one, you had a good shot of, convincing them to vaccinate their kids too. So there's a case where, you can do both at the same time. But I mean, in Western medicine, we're really not going to be having clinics where we're vaccinating dogs, cats, and humans. Um,
I guess I won't comment on that. Um, so
yeah.
I did. Sorry, Justin. I know that did you have a question, Justin, or I?
I'm just enjoying hearing or respond to your questions, Bryce.
Oh, okay. I'm glad you can at least hear me tonight, as opposed to last night.
You're coming
So
through loud and clear.
okay. So then when you said, so you also said when there's a One Health activity. So when you
Right.
say One Health activity, does that mean you're talking about conferences, or is that what you
Right.
meant?
Right. Education, conferences, you know, joint activities where you can talk about spillover risks it's One Health originally focused on zoonotic diseases, but over time it's really evolved to encompass much more, including antimicrobial resistance, which has a huge environmental and animal component, as well as food safety and security, which I've talked about before, but also agriculture and climate change, the human animal bond, comparative medicine. My colleague, Dr. Barbara um, Natterson Horowitz, wrote a book called Zoobiquity, where she recognized, and this has been long recognized by the veterinarians, that disease processes across species are shared so that animals get asthma, heart disease, cancer, they get obsessive compulsive disorder. I mean, all the illnesses that we've always assumed are unique to humans really are not. The animals get all of these illnesses too. And some of the greatest breakthroughs in the history of medicine and public health were made at that human animal interface. I mean, look at smallpox vaccination. That the whole concept of vaccination, vacca, comes from the Latin word cow. Dr. Edward Jenner recognized that people who got cowpox didn't get smallpox. And there was this practice called variolation that was developed sometime in the Far East. Nobody really knows when it started, but you would take dried pus from somebody recovering from smallpox and scratch it into the skin, usually of a child. And that practice would help to bring the mortality rate down from about 30% to around 1 or 2%, which was much better. So that practice spread to England, and it was a leap of insight by Dr. Jenner, who thought to use cowpox pus instead of smallpox pus to scratch into the skin. Uh, and um, and that's how we got our smallpox vaccine. I mean, it wasn't without its problems, but it was safer than the smallpox, the practice of variolation.
I guess one thing I'll say as an aside, I do think I would like you to join my bar trivia team. Sorry, but I was gonna. So here's what's fascinating to me, because you again mentioned over
Uh-huh.
time the meaning of that term has evolved. So this is where I want to discuss how One Health became associated with the work of Peter Daszak and EcoHealth Alliance.
Right.
Are they just taking a nice phrase and like
Yeah.
exploiting it Is that all that is? Because are they
From my
I get,
perspective, I mean, for me, One Health was just increasing communication and collaboration between the professions, the physicians, the veterinarians, just facilitating greater understanding of these microbial diseases that spread across species. They took it a one step further and decided to start futzing with the microbes themselves, particularly viruses, doing things to make them more communicable or deadly. To me, that's not one. I mean, that never in a million years would I have thought of doing something like that in the name of One Health. That was not. That was not in the One Health resolution that I wrote, and it's certainly not anything that me or my colleagues or I advocate for doing gain of function research on pandemic potential pathogens. Now, there is gain of function research like turning harmless bacteria into insulin producing machines. That's fine, but it's the making the pandemic potential pathogens worse. I mean, we don't need to help Mother Nature kill us. Mother Nature is quite capable of killing us without helping. So that was never part of the plan of One Health.
So, Laura, I'd like to follow up on that because this
Hmm.
seems to be really the crux of the motivation for doing, at least the publicly stated motivation
Yeah,
for doing, for creating enhanced potential pandemic pathogens. Um, so, part of this idea is that, well, we want to know what viruses are likely to be transmitted from animals into humans and thus cause a pandemic. So the idea is you go out into remote regions, survey all the viruses that are there,
right.
and then you take them back to the lab and you figure out what needs to change to make them deadly to humans.
It's
So
crazy. Yeah,
yeah. I mean, it sounds insane, and
yeah,
I think, and it is insane, but that's the rationale.
right,
But I think one thing that I really haven't heard are experts on zoonosis talk about, does this make any sense as a strategy as opposed to, I mean, I can imagine other things like, if you're worried about viruses jumping from animals into humans, maybe you
right.
should focus more on the animals that are interacting a lot with humans and the
Yeah,
common viruses that they have. But I'd really like to hear your thoughts on this general rationale for this virus hunting and virus manipulation research.
right. So, well, I mean, I think, for example, there's a good example of how they could have taken that leap of you know uh, extrapolating the concept of human and animal health, the Nipah virus outbreak in Malaysia. That was, I think, the first time that virus spilled over from bats into pigs into
Hmm.
humans. And that was a case, it was in the late 1990s. There was a lot of deforestation, a lot of destruction of the bat's habitat, and it was spending more and more time around the pig farms. There was a huge buildup of pig farms, and the bats were eating the fruit around the pig farms. They were contaminating it with their urine and feces and secretions. The pigs started eating the contaminated fruit. They got sick with this virus, and then pigs generate a lot of secretions, aerosolize those secretions, and the humans got sick with these awful uh, neuro, you know, neurological diseases with a high mortality rate. And that's when Nipah virus was discovered. So
Hmm.
they probably took that example and decided, well, we need to go, survey all these animals, particularly bats, to see what viruses they harbor and what else might spill over into humans. Because, we had never, there was Nipah, there was Hendra, lots of bats harbor a lot of really deadly viruses. So they're trying to jump the gun and identify the viruses before they spilled over. Uh, and you can understand their rationale to try and prevent that from happening. Maybe develop a vaccine for the bats or something. Um, but if you're not destroying their habitat, I mean, ideally, you just keep the animals separated. Don't destroy the habitat for the bats and keep them away from the livestock or from the humans. Uh, so, a One Health approach would be, but well, let's make sure these bats have an intact habitat so that they're not going to rely on the fruit trees around the pig farms.
Another thing that really has just confused me and just has never made any sense to me is there seems to be a real um, idea in the virology community and maybe even parts of the public health community that sampling viruses from remote regions and bringing them back to population centers,
Mm-hmm.
much less, you know, trying to increase their transmissibility or virulence in humans, itself presents an obvious risk.
Yeah.
But there seems to be just denial among scientists involved in this kind of research that that's a risk. And it's almost like the flip side, like there's one threat, right?
Mm-hmm.
The one
Mm-hmm.
threat is human contact with these viruses, right? And
Right.
and
Well,
however the humans are exposed, dangerous. Um,
yeah.
and I don't know. I was just wondering if you have any thoughts on just that seeming contradiction, or
Yeah. Well, as humans, we like to think of ourselves as kind of above nature, that we're just kind of immune from it all.
right.
That's a real kind of speciesist perspective that we have. And I'm not going to go into the kind of the religious philosophical overtones of all of that, but for centuries we think we're better than the other animals, we're above them, and we're immune, when that's certainly not the case. There's also a certain level of kind of um, macho ideology behavior with some of these scientists, talking about going into the hot zone and winging it alone kind of thing. I mean, just kind of listening to some of them talk, or, listening to other people give similar observations of this kind of, omnipotent belief about themselves, or breaking the rules without really thinking about potential consequences. Um, you know, uh, this thought that, well, we're scientists and we know everything. I'm just kind of speculating. I mean, I haven't done any studies certainly on the ideology, but there seems to be that element as well, without really thinking through the consequences of their actions.
So I know that you've written about the Banff laboratory
Hmm.
being and the research being built in Manhattan, Kansas, and
Right,
research on agricultural pathogens being moved from Plum Island to the middle of
right,
the middle of cow country,
right.
and that yeah. So I was wondering if you could, and that seems to have similar themes in it, in
Right.
that people are ignoring an obvious possible problem. But you were writing on this in the 2010s.
Right.
Yeah, could you expand on that?
Sure. Well, I mean, I thought, when Plum Island was established, I think it was like back in the early 60s, people had a healthy respect for microbes. And they located the lab at Plum Island deliberately because they knew that if there was a lab leak, and the virus of greatest concern is the foot and mouth virus. I mean, this
Right.
virus hitchhikes on clothes, on tires. It can travel, hundreds of miles over open ocean. I mean, it's one of the most extraordinary viruses. I mean, it really spreads. I mean, there was a 2001 foot and mouth outbreak in Great Britain. They wound up slaughtering 6 million animals to bring it under control. So it was very smart to put, if you're going to research, livestock diseases, it's very smart to put it in a remote island with the prevailing winds blowing out to the open ocean, to
Yeah.
protect against any kind of leak. And
Yeah.
here
I
they
mean,
have
it
the
sounds like,
audacity to move this
yeah.
lab from Plum Island to Manhattan, Kansas, smack dab in the middle of livestock country. It just, I was just shocked, just
And
shocked.
this was, and can you expand it on? Can you say more at all about the outbreak in the UK in 2001? Because I know
Right.
Allison, yeah,
Yeah. So there was the outbreak, and they think it was from contaminated meat that might have been fed to pigs. Um, Pigs are big, as I said earlier, they generate a lot of secretions and they're very good at spreading the virus. Sheep are kind of silent spreaders, and the cattle get really sick. So, I mean, it was just by the time they identified that that a lot of their herds were infected, it had already spread around much of the country,
hmm,
and they were chasing after it, and it was just a disaster. It was also, interestingly, the first time that they used mathematical modeling to develop policy,
huh,
and the mathematical modelers came up with this concept called contiguous cull, where not only would they
right,
slaughter all the animals in the infected farm, but they would slaughter all the animals in the adjacent farms to try and create a firewall, if you will, of the
right,
virus. But they wound up just slaughtering tons of healthy herds in unaffected regions to create these firewalls. 6 million animals. A lot of the farmers committed suicide. They were just,
oh
it,
God,
it was just, such a devastating, um, and some felt highly unethical response. But of course, the modelers insisted that their models brought the outbreak, the epizootic under control. So it depends on who you talk to. The perspective of whether or not it was a success or utter failure. I
so
don't know.
in her book, Pandora's Gamble, Allison Young writes about um, a vaccine plant in the UK leaking foot and mouth
Mhm.
disease. Is that the same event,
That
or
was a different subsequent outbreak.
yeah?
There was a leak from a lab, a small outbreak that they were able to quickly squelch. That was a
So
number of years later.
so, but that's like an explicit example of
Yeah.
foot and mouth disease leaking out of a lab and contaminating cattle in the
You
nearby
know,
region.
that's why I was concerned when they decided to move. You can have the most secure facility, but, a lot of these errors are human error. People
Yeah,
just, when you read some of the reports and, test tubes break or people forget to, wear a mask or, an animal that they think isn't infected is infected and they get bitten. I mean, these things happen all the time.
right.
So you never say never.
Well, I very much worry about virologists not distinguishing between like the safety measures you need to have reasonable assurance that that if those safety measures are followed,
Hmm.
then you have reasonable assurance of not getting a leak from that specific lab. That's a like that's a very different thing than saying what measures do you need to make sure that no lab doing this sort of research is going to leak it if there are like hundreds of these labs, taking into account the fact that not all of them are going to follow the proper safety protocols.
Right.
And it's starting to look more and more like SARS-CoV-2 might have been an example of this, where if it had been done in the US, it would have likely been done at BSL-3, but it was being done in China at BSL-2. Now,
Right.
even if there
Right.
was a lab leak, it's not clear that that was the main problem. But
Well,
just
that
saying,
particular
yeah,
lab was noted for having safety problems to be, beforehand.
right,
So, I
but
mean, there were
it did affect
reports
with
of
the,
that
yeah,
poor safety practices.
but
So,
that did not affect their funding, like including from the US government.
evidently not. Evidently not.
I did.
So, yeah, go
Sorry.
ahead, Bryce.
Yeah, I guess I had a couple questions. Just going back to something that I didn't appreciate that you said about the foot and mouth disease
Hmm.
outbreak with respect to the use of mathematical modeling.
Hmm.
Was that Did that then become standard practice, or because it sounded like I wasn't aware of the controversy that people
Hmm.
objected to the modeling that was done.
Right.
But then did the is that how did that change policy moving forward, or did it?
Well, I think, mathematical modeling is extremely popular for modeling diseases across the animal populations. I believe it's being used increasingly in policy, although, um, when you're dealing with, and for example, they did use it in COVID. Uh, in Great Britain, mathematical models. And I think some of the modelers were suggesting to just let it rip. And that generated so much controversy that they shut that down, in terms of trying to figure out how fast was this virus going to spread, and how to handle, quarantine. I think at that time the vaccine wasn't available. The thing is, with when you're dealing with humans, you're dealing with a lot more politics because people are going to be opposed to policies that might curtail their freedoms, as we saw here in this country. um, you can, some models might be considered unethical. As I said, the foot and mouth disease mathematical modeling of the contiguous coal policy was considered unethical by many veterinarians, certainly others as well. So, the models might suggest something, but if it's considered unethical, then you can't do it, in an effort to curtail disease spread. So it's not an easy thing to do. I mean, I think mathematical models can be fine for research purposes, but I'm not sure it's quite ready for prime time for active pandemic response. Because, look, if you don't really know the data very well and you make assumptions in your model, those assumptions might be wrong, and then your output might be completely off. So, maybe machine learning and artificial intelligence might help. I don't know, but still, you need to input valid data in order to
Well,
get a reasonable out policy output.
I'm connecting it to, I believe, the data that was used to drive a lot of the policy decisions in like the Vietnam War. I guess I keep drawing it back to this analogy of using, similar strategies when you're dealing with war and dealing with like viral outbreaks. And
Mm-hmm.
the idea being that it gets to this idea of hubris that we were
Mm-hmm.
talking about a moment ago, where somebody, I mean, imagine having a mathematical model, being the person that comes up with that, and that is arguing for that model when, if it's off by a bit, can cause catastrophic loss of life. I mean, that's
Right.
an incredible burden potentially, although perhaps, I don't know. I mean, I think I guess perhaps this means that and maybe this is a lot of what you've written about is strategies to actually prevent having to even be implementing these models in the first place, to make these decisions,
Right.
because you
That's
prevent it.
preferable.
Right. So I guess that being said, I did want to ask you about one of the things I'm just always amazed by about, the Biosafety Now leadership team, is, having being someone that's new to this space. The expertise of the people in the group, including yourself, is quite remarkable. And the breadth of your knowledge, and the fact that you've written things, long time ago, that are relevant to this day, um, including, I guess, one of the. So this wasn't so long ago, but in I think it was 2009, right, when
Hmm.
you wrote about licensing of, or a
Hmm.
proposal for licensing of scientists. I don't know if you
Uh-huh.
want to. Could you say something about that? Because I think it's quite relevant for today to think about, should scientists have to go through some sort of licensing procedure to carry out their work?
Right. Well, licensing is an effort by the state, and in the U.S., it's state by state. We don't have national licensing, which I think is important to point out. So different states have different requirements, but licensing tries to protect the public uh, and to ensure minimum qualifications. That's different from board certification by the professional boards, which is an effort to assure the public of a certain level of excellence. So, by licensing, you want to ensure minimum level of competence, or maybe medium level of competence, whatever standard you want to set. But if you want to practice medicine in a certain state, you need to pass certain exams. You need to have gone to an accredited medical school, and in order to meet the licensure standards. So, so you could apply, and a number of professions. There's nursing. There's even being a hairdresser. You need to be licensed in order to cut people's hair. You can't just sit up a stand and start cutting people's hair. You need to be licensed. So there's a number of professions that require licensure to protect the public, and it would make sense if you're dealing with pathogens in a community. You want people to be able to demonstrate a certain level of competence to show that you know biosafety and biosecurity, and that you know what you're doing. Um, so that's why I argued in favor of licensure.
But wasn't that 2009 or 2011? I don't
I
know.
don't remember the year that I published that I put that out.
But did anybody, like, follow up on that idea, or is that something that's just
Now
sort of
that went into the wind.
right? So I guess
I wrote a lot of stuff that went into the wind, Bryce. a
no,
lot of
but
a
that's what I
lot of
mean.
stuff.
Hey, listen, I think I know the feeling. Trust me. There's some papers I have. We've all done that. We've all done that. But it is important. But that's actually one of the things that one of the
Hmm.
goals of Biosafety Now, and having the website, YouTube channel, and the Twitter Spaces, to bring back some of these things, like thoughts that you had
Yeah.
decades ago that are relevant now.
Yeah, and things
And
haven't changed, unfortunately.
nothing.
So
Yeah.
it's sad that it took a deadly pandemic to get people. I mean, I was hoping to prevent a pandemic, but we tend to be a reactive species rather than proactive, and it usually happens after the fact that we finally start paying attention to these things. Unfortunately.
Well, that goes to the One Health initiative too. Going back to
Hmm.
that, because the whole point of that is to be proactive, and that's
Exactly.
where I guess I want to turn back to that to ask you, um, how do you get that back? How do you restore One Health to where what it was intended to be? I know you've written about having One Health, like programs, like graduate programs. I don't know if
Right. There are some in schools of veterinary medicine. There are some in public health, schools of public health. There's a growing recognition of the importance of One Health. As far as I know, no medical school has included One Health in their curriculum. So it's right now mostly an interest in public health, although there's still resistance to that because people don't like change. Uh, One Health is, again, more embraced by the schools of veterinary medicine. But look, our conversation here and the establishment of Biosafety Now is an important, strategy, venue to bring One Health back to where it was as strictly a proactive way to improve how we respond to, zoonotic threats, antimicrobial resistance, all of these things. Doesn't require futzing with viruses. It's simply an improved way on how we live in our microbial world by recognizing that we're part of nature, not above it, and that we need to change our infrastructures to reflect that and to work together rather than in our silos. That was the push for One Health.
So, and in fact, it's fascinating too, given the connection again, with Richard Ebright being involved in antimicrobial resistance and
Mm-hmm.
talking about really a lot of that's about changes in public policy rather than more
Mm-hmm.
research. I mean, this
That's
also,
exactly right.
um,
And yeah, and interestingly, there's a huge environmental component of antimicrobial resistance that is not getting its due because it appears that resistance genes are naturally occurring and ancient. And so we're changing the microbial ecosystem of the planet in ways that we don't really understand. And, microbes are much better at collaborating with each other, sharing resistance genes than we are in developing new antimicrobials, and we're losing the battle.
So,
Uh,
so
yeah.
Laura, this is bringing me back to this statement you made about public health being the Cinderella
Mm-hmm.
and reductionist medicine,
Mm-hmm.
reductionist scientists getting the focus. And it almost strikes me as, you know, that might be, one of the drivers of this weird push in the name of One Health to reduce it to actually very reductionistic studies on viruses
Yes.
and
Yes.
technologically heavy, right? Because I
Well,
can imagine
Bryce,
that there,
it's
yeah,
it's
go
a
ahead.
lot sexier to futz with viruses than it is to just improve communication and collaboration,
Right.
well, no, not
right?
if, well, Laura, see, I have a proposal here. I have a proposal. We don't call it One Health, we call it Hot Zone. What do you think? I think we might have a winner. That way, people would be supportive of it because it sounds exciting.
Yeah.
Um,
Yeah,
yeah, no,
One
you're
Health,
right.
I must admit, is not, it's not sexy, it's not exciting, and it just can't generate the enthusiasm that we need to implement it broadly.
I'm very into trying to come up with branding and marketing strategies to sort of solve this issue. I think it's yeah, because really what you've pointed out here is simply that it's kind of a mindset,
Yeah,
but it's such a so and you can take that mindset and do great things with it, or you can just use it to sell your kind of
yeah,
dumb agenda,
that's
not
right.
well thought out agenda, to just get money
Yeah, I
from.
mean, we put the concept out there and people did with it what they wanted. Some people have really worked hard to, reduce disease in areas like, developing countries, really working hard to reduce, disease transmission. And others, decided to do gain of function research on pandemic potential pathogens. I mean, you know, we didn't have control over the concept. It was just, you do with it what you want. And unfortunately, some people did things that, many of us consider unethical.
You mentioned global implications here, but I did wonder, you said it was begun by those are American institutions, right? The AMA and wasn't it
Yeah, the AMA and the AVMA, right.
so it was started as a US based initiative, right? So how
Well,
do you
primarily, it kind of grew organically because there was our group. There was a group in Switzerland that was working on one medicine at that time. There was the wildlife folks. They had their Manhattan Principles back in 2004. They met at Rockefeller University. So there were a number of like little pockets here and there, but it was really the AMA and the AVMA meeting and this, One Health resolution where it really started taking hold.
One other thing I would mention, I think you mentioned you were talking about hantavirus and the way
Mm-hmm.
that was discovered, and maybe someone can correct me if I'm wrong about this. I'm pretty sure that and maybe that was the story or the narrative that Daszak showed in when he was first on 60 Minutes, I think in 2004. I
You mean the
think
Nipah virus?
sorry, the Nipah virus. Yeah, I'm pretty
Yeah,
sure is that correct? Am I remembering that correctly? I know that.
I don't know. I don't know what he used to justify.
But it was the exact same story about
I'm right.
secretions
I could
and
see how he would use it though, because it is kind of your classic story of a previously unknown deadly virus, in the guts of bats. Um, so, I mean, you could see how he could use that story to justify going out and looking for more viruses, deadly viruses that might spill over. But why search for them? Leave them in the animals. Leave them alone. That's uh, want to have a healthy respect for the microbes and on our planet, and sometimes it's best to leave the sleeping tiger alone.
Hey, Laura, I have a question for you. More generally, the the more I learn about uh, gain of function research on enhanced potential pandemic pathogens, the more it seems, and these virus hunting efforts, the more it seems to me like the only real rationale is biowarfare. Like, there it makes a lot of sense to go
Hmm.
out and find new viruses and
Hmm.
figure out how they can be changed to infect humans. Um, but I'm wondering if you've encountered, and I know that the biodefense in the U.S. was run out of the same funding agency that funds a lot of same primary funding agency that funds research, academic research on viruses, and public health research on viruses, the NIAID, that Fauci headed. I'm
Hmm.
wondering, um, have you encountered any like interface between biodefense and public health, or other people in the One Health kind of network that has caused you concern?
Well, I mean, there's long been discussion that you know the previous term was dual use research of concern, another vague acronym uh, that was kind of a dry term, but the the challenge with that, what it means, dual use, is that the research could be used either for benevolent or malevolent purposes, depending on the intent of the researcher. So, any research that involves things like gain of function, we assume it's going to be for benevolent purposes, but it certainly could be used for malevolent purposes as well. Um, I mean, if I don't know if this was a intended bioweapon. I don't know. There's some have speculated that, but I don't have security clearance.
Yeah.
I don't know about that.
We did talk about that last night, Justin. I guess
yeah.
I think a lot of it got muddled. I guess one of the issues, and some of the people in our group have, I believe, even written about this, is the idea that no rational actor, whether you're classified as a terrorist or a state, would develop bioweapons for use. It's not a logical thing to do because you can't control them. That's
Yeah.
an argument, and I guess Ryan McIntyre is quoted as saying that in a recent U.S. Right to Know article, and that's something that Milton Leitenberg, I believe, has written about. The examples where bioweapons have been used, biological weapons have been used, have either been individual actors, such as the
Mm-hmm.
anthrax attack,
Mm-hmm.
or cults. I forget the name of the one in Oregon, and then of course,
Rajneesh.
Rajneesh.
yeah.
Yeah.
Again, I guess so.
Shinrikyo was incapable of using anthrax, so they resorted to sarin chemical.
Oh yeah.
But I guess the point is, and I guess I mentioned this last night, and I guess want to reiterate it, that the claims of what the Chinese were doing are no different than what we publicly admit to doing, which are making viruses that don't exist in nature and simultaneously developing vaccines, or at least claiming that that's the goal. So, however you pitch it, that's the way it's described in that Times article, but it's discussed as a bioweapon, as a Chinese bioweapon. But again, that's the way that Dazik describes it. So I'm, but one thing I guess before I do want to take some questions if anyone has some, but we're going to let wrap it up in a little bit. Did you have any thoughts, Laura? I know we talked earlier today about keeping our sanity. Do you have any calm thoughts about why it's taken so long for the information that seems to be, coming out now about the names of the people that were infected? Do you have any thoughts about that? I guess.
I guess the question is, how long have people known about these names, and why are they coming out now? It's just pure speculation, but how long have these names been known, and why haven't we been notified earlier?
That's pretty calm.
Is my top thought.
It seems sad that it's taken so long. I mean, if somebody does want to, I would, if somebody wants to yell about that, I certainly understand. Because
Right.
it's been kind of ridiculous. That it's taken so long for that information to come out publicly.
Sorry, can I yell about that briefly?
Well, maybe. Sorry, I guess I'm not sure. Can you explain it? Because I'm sort of actually talking about something
Yeah.
maybe not everyone knows.
There were reports last week that the three scientists at the Wuhan Institute of Virology. So we've known for a while that three scientists at the Wuhan Institute of Virology got sick with COVID-like symptoms in November of 2019. So we've known that for a while, but the article that first reported that said, well, it's also consistent with seasonal flu. There were articles last week saying, actually, those three people are Ben Hu and I forget the other two names, but they're exactly the three people you would expect to be like doing gain of function research on SARS-like coronaviruses.
Oh, man.
Like one of them is the person whose master thesis describes the collection of viruses from the Moajing mine where they got RATG13. The other one, Ben Hu, is listed on the diffuse proposal as being kind of the person who's going to lead the genetic engineering. So it's like exactly the three individuals you would expect.
Right.
So, and these infections come before any of the verified infections at the Hunan seafood market, which were all in
Mm-hmm.
December.
Mm-hmm.
So, I would, so it's really okay. So the articles last week though went further and said that these were the patients zero,
Mm-hmm.
that these were the first patients to get COVID. Now today there was reporting in the Wall Street Journal that confirmed the names of these three scientists, but it did not provide any more information about the symptoms that they had, or about the whether they were patient zero,
Mm-hmm.
the first three people to get COVID.
Mm-hmm.
Um, and it, yeah, and it did not either provide the dates. So, to my mind, there's still kind of a difference between
Mm-hmm.
late November, like first getting sick in late November and needing hospitalization in early
Right.
November. But either way, it's becoming pretty clear that COVID was a lab leak. It's just
Oh,
really like this is
yeah.
just getting into ridiculous territory. Um, you know,
Yeah.
I think one of the strongest pieces of evidence for a lab leak the whole time has been that the outbreak occurred in Wuhan, which
Right.
is which houses, uh, the the outbreak occurred within commuting distance of the one lab in the entire world most likely to be working on exactly this virus.
Right.
Um, but we now know the outbreak occurred, or something, you know, at least there's a decent chance that the first few people who got it were the people most likely to be constructing the virus at the bench.
Yeah.
Um, so it's really just straining credulity that there would be any sort of explanation, that zoonosis is an explanation. I think it's important for people to realize that, um, the evidence for this is something that's often missed in discussions of the evidence for zoonosis. Um, is that the evidence for zoonosis relies primarily on mathematical modeling. There were two key papers in Science magazine in 2020 by Pecker et al. And Werribee et al. They're not
20,
traditional.
22, I think.
Sorry, 2022. Um, and these are the primary papers cited for, including by people who still claim it was, that the SARS-CoV-2 has been proved to come from, to have originated as a zoonotic spillover. Um, those papers actually rely on a lot of rather opaque mathematical modeling.
Mm-hmm.
Now, I do mathematical modeling for a living, and I'm super suspicious of it,
Mm.
because so much can turn on one or two small assumptions hidden deep in the
Mm-hmm.
supplemental material or not even explicitly stated. Um, And I think that those models are likely to be very fragile. The models used in those papers are likely to be very fragile to many
Mm-hmm.
different forms of ascertainment bias. Um, Meanwhile, it's really hard to explain how you get these specific three people with COVID-like symptoms in November of 2019,
Right.
with any sort of plausible explanation.
Well,
Anyway,
yeah.
so that's the reporting that came out, today. So it's not as definitive as I would have liked, but I think it almost looks well. Anyway, yeah. So that's the current state
Right.
of,
Well, let me just
yeah.
jump in because in the research for my book that I hope comes out relatively soon, I did a deep dive into comparing, what were the criteria that was used to confirm that both SARS and MERS were indeed spillover events. And the criteria was that, antibodies and or the virus were identified in humans and animals. In the case of SARS, you had the civet cats that were in the market with matching virus or antibodies to the virus, matching very closely to the humans. The humans that were most likely to have the highest titers were those who were working with the animals. In the case of MERS, they had archival data going back decades in camels showing that they harbored antibodies to the MERS virus. And the people who were most likely to have antibodies to MERS were those working in the camel slaughterhouse or were working with the camels compared to the general population. So you had occupational exposure, and you had the identified animal, neither of which were evident with COVID.
Right.
So that data did not exist.
We have two questions, and then I'll get to my questions about why, if the safety standards were so lax that they let a raccoon dog work in the Wuhan Institute of Virology. First, Gregor, will you unmute yourself and
Yeah, sure.
Okay, go ahead.
Okay, thank you. I also have issues with the term of virus hunter. I think the hunter is a deeply propagandistic term and would need to be replaced by something like virus collector or virus harvester. I mean, that's what they do. They go in there and they harvest viruses and then they try to turn a profit with them. I think that I would never use virus hunt. I've also noticed virus hunt repeatedly being used in this propagandistic manner.
Well, hunter has a much sexier connotation than purely, gathering. The harvester is, less macho than hunter.
Well, I think
I don't have any strong feelings about the terms, but I can see your point.
Well, I think you really have to think about what actor you want to play in the movie. Do you want
right,
Bruce Willis or so anyway.
Yeah.
Well, we have, I guess the way to, stamp collector is another expression that's sometimes used. So, Dr. Katie, you have a question?
Yes, hi, and thank you. I'm curious to know if those first possible 3 patients, 0, survived.
I don't know. Was there a report on what their status?
All of them survived.
They all survived? Okay.
All of them survived, and apparently they were at some conference in January, and or at least Ben Hu was. But yeah, all of them survived.
Thank you.
So all of them survived, but it's still, the report are still that they had to be hospitalized, like they were severely ill, but more specific information about, there's 3 of them, what specific symptoms did each of them have, what were the dates of onset, that has not been released.
Yeah. All right.
Scarlett?
We appreciate it.
By the way,
sorry.
I just wanted to point out the Biden administration blew through the legally mandated deadline on Sunday for releasing all U.S. intelligence on the origins of COVID, specifically releasing the names of these people and this information about the symptoms that they had, and so on. So right now, the administration is just blatantly breaking the law by not releasing this information, which was passed unanimously by Congress and signed by Biden himself.
I also wanted to quickly add something about the 3 Chinese virologists.
Wait, hold on, Gregor, can you wait 1 second? Let me just ask Scarlett to ask the question and then come back to you.
Sure.
Thanks, Gregor.
Yeah, hello everybody. Thanks for this space again. So a couple of years ago, Dr. David Usher from the Hudson Institute, he gave a couple of YouTube videos where he spoke about the potential bioweapon prospects that China was exploring. Any further follow-up on that? Why has he become silent of late? Thank you.
I don't know, Laura. Do you want to say anything about that, or I'm not sure. David Asher,
Yeah.
right? So I think interesting. I was I need to reach out to David Asher. I think maybe I wonder if he would do a space with us.
Mm.
Curious. I was actually thinking about that, so maybe we could have him
Yeah,
on.
that would be great. Have him on to
I
talk
don't
about
know
it.
because I know he does follow our account, I believe, and I know he's been pretty vocal about believing. I believe, right, that he believes it's a lab accident or research related something, right? So that's interesting. You brought him up, Scarlett. I'm thinking he was actually on the list of people I wanted to contact to see if he would come on a space and sort of talk. So if he does, then you could certainly ask that question. But I don't know, like sometimes some people can say certain things and not other things. Who knows?
Right.
I don't know.
Right.
Gregor, you had a point you wanted to make that I cut you off on?
Yeah, there was a second point I wanted to make about the three Chinese virologists, Ben Hu and the other two, and the November date. I'm actually not happy with the November date. It doesn't make sense because there was so much stuff happening at the Wuhan Institute of Virology in September already, like switches from civil to military control or the databases going offline. So them getting sick in November is about 2 months too late. I don't like the date. It should be a couple of months earlier. I don't believe the November thing. It should be earlier.
Oh, I see.
So, if I can just comment on that, I know where you're coming from, Gregor. So, I had heard reports that these researchers were actually sick in October, and I agree with you. It doesn't quite square with the reporting from ProPublica and Vanity Fair about the biosafety alerts that seem to have gone like the Chinese government involvement, um, uh, uh, various biosafety related events at the lab that were deemed to have happened in September. But this is why I think knowing the dates is important, um, and having more insight specifically into the timelines and the symptoms are important. But no, I think that's a fair question.
Dana, did you have a question?
Yeah, first of all, hi guys, and hi Laura. It's so great to hear you.
Hey. Thanks, Dana.
It's great to hear you tonight. Thank you so much for all the great information you're sharing. And as you know, because I've told you like 1,000 times, I was so impressed when you tweeted about Bartonella. And it was a big part of our book because it's such an important and overlooked vector-borne disease. And I wanted to see if you would just talk a little bit about the neuropsych stuff associated with it and PANS, because I think it's a huge black hole in medicine for most clinicians. And I any chance I get to talk about this, I think will really help people.
Well, thanks, Dana. Yeah, Bartonella. I mean, it's one of these kind of stealth microbes. Very hard to diagnose.
Yeah.
Very hard to treat, and it seems to be turning up in a lot of really strange cases, including possibly schizophrenia and other severe neuropathological diseases. I mean, Bartonella can come from infected cats, particularly kittens, but it can also spread by fleas and lice. According to the CDC, not ticks.
Although I got it from a tick officially.
Did you really?
I did. And I think the whole thing about it being in ticks but not spreading to humans is just so bizarre, because I know tons of people who feel that they've gotten it. I had to direct the whole thing, the tick bite, the lesion, the whole thing, for sure. Yeah, it was really, really terrible, and it's a horrific infection that caused I got heart failure, and yeah, it was really, really scary.
Yeah, and I think let's see, the author of Bitten, I'm blanking. Chris Newby wrote about a young man Bartonella.
That was such a great piece.
Swamp Boy.
Yes, amazing. Yep.
That was a really compelling article. And then, this most recent one from the Washington Post about this woman with schizophrenia who ultimately was identified as having Bartonella. And it makes you kind of wonder how many people with severe mental illness have it because of an occult Bartonella or maybe some other microbe is causing their illness.
I could not agree more. I just interviewed a couple of psychiatrists for a podcast that's coming out soon who specialize in the neuropsych manifestations of stealth chronic pathogens like Bartonella.
Yeah.
And fascinating topic, and so true what you said, like how many people are suffering and have no answer. They get put on psych meds. They don't work that great for them. And then, they find out years and years later, if they're lucky, maybe they had an infection and can treat it. I hear a lot of that, but it's hard. It's really hard.
That's when I talked about the reductionistic approach to health and disease and how a lot of physicians get into their mindset, there's no way that this disease could be caused by a microbe, and refuse to even consider it or test for it.
Yeah.
And again, Bartonella is very hard to diagnose, which makes identifying it and treating it so much more difficult. But, the whole notion of the microbiome is really in its infancy. I mean, we don't know that much about the microbiome of the planet, the ecosystems, much less, we're walking ecosystems, our entire body. I think Ed Young wrote about it in the book, We Are Multitudes or something like that. And I foresee some time in the future where when you go for a checkup, they will check your microbiome.
That's so interesting. That's so interesting. Yeah.
And they're identifying that people with certain conditions have a unique kind of fingerprint, if you will, of the microbes in their guts or on their skin. That's different from somebody who might be healthy. They found that people who are thin have a different gut microbiome compared to people who are obese. And there's, talk about, you can have a gold mine in your gut. If you're thin and healthy, you can sell your gut microbes and make a lot of money.
Yeah, interesting.
Again, I think this is all in its infancy, and we're just we're really at the very beginning of understanding this whole dynamic. So, but I think that's going to be medicine of the future. It's certainly not today.
Well, and I just wanted to chime in on that. Like, there's also, I think, a rapidly growing appreciation in fundamental biology of the interconnectedness between the brain and the immune system, and physiology. So, I mean, I know, where I work, that's actually a major focus of research now. And so I would not be surprised to see, many, a lot more systems level descriptions of diseases start coming out, because there is a lot of really weird stuff out there that's hard to explain if you think of each organ in isolation.
Yeah, I mean, that was one of the things that I didn't like about medicine, was that you studied each organ system in isolation of each other. And when you go to the doctor, you're seeing either a cardiologist, we've divided up medicine into organ systems, and they usually don't talk to each other. But we're learning that, it's a system. And as we're discovering that, our bodies, multicellular organisms such as ourselves, they communicate with each other through either hormones, chemicals, the way bacteria communicate with each other by chemicals. Our cells communicate with each other by chemicals or by, electrical currents. not too dissimilar from the way trees communicate with each other through the fungal network that serves kind of as a neuron, if you will. So there's lots of parallels here that are, that we're just discovering now. I think, again, I think the practice of medicine is going to change dramatically in the decades ahead. Far different from what we're experiencing now, but we have a long ways to go, unfortunately. But it really should look at it all as a systems and how our bodies interact with the microbes that are on us and in us and around us will determine how healthy or sick we are.
So, if nobody else has any questions, I don't know, Laura, do you have any final words about One Health that you want to say?
Yeah, I mean, there's different ways on how people visualize it. I think of it as a way to just approach health in a systematic, comprehensive way to allow systems thinking, recognizing that, looking at our lives as part of a system on the planet, this microbial system with the other animals, with the plants. We're all sharing microbes. There's the animal microbiomes, there's the plant microbiomes that are called phytobiomes. These fungal networks that we're learning about. It's all kind of interconnected, and I highly recommend this book written by, I believe, Andrea Wolf, called "In the Discovery of Nature." It's the life story of Alexander von Humboldt, and he kind of was the first to recognize the interconnectedness of life on the planet, we have to kind of rediscover that, because he discovered it very early on, but it just didn't seem to take hold, and we seem to have to rediscover it again and again and again. That we're part of life on the planet. We're not above it. We need to have a healthy respect for the microbes and for nature, because if we do them in, then we're going to do in ourselves. And for me, that's what One Health is really ultimately all about, is just trying to figure out a more sustainable way to keep ourselves healthy and to keep our planet healthy. So I'll just end with that.
Scarlett, did you have one final thought?
Yes, so part thought, part question. So, in traditional agrarian economies and societies, I come from India. So, in India, there are still villages that practice agriculture which they did 300 or 500 or even 1,000 years ago, and people are perfectly hale and healthy. And believe it or not, the kind of food they eat, it is completely different from what people in Indian cities also eat. I mean, none of them eat refined food. It is all very raw. I'm not saying organic. They've been eating the food the same way they have been eating for hundreds of generations. They're perfectly healthy. So, do you think that the kind of vast changes in overall lifestyle patterns have actually destroyed our systemic microbiome, connection with lives?
Thank you for that question. Absolutely. And in fact, you go into any grocery store here in the US, and the food that's healthy for you is on the perimeter, either on one end of the store or the other, the fruits and vegetables or the dairy products. All the crap that's in the middle, that's in boxes, is garbage. Aisle after aisle after aisle of
That's a great way to put
garbage. And I just walked right past it all to go from one end of the grocery store to the other, because that's the only stuff that's reasonably healthy. So, people are buying all that boxed crap and they're eating it, and we've got very sick populations. So yes, I agree with you completely that our lifestyle here in the many countries is terrible. The food we eat is terrible. this is a subject for another whole another whole Twitter conversation that I wasn't planning on getting into, but I agree with you completely. That's another whole conversation I would be thrilled to have. But I'm not sure people want to stick on and listen to me rant about our Western lifestyle at this point.
Thank you, Laura. I was going to say, I just noticed that Chris Newby popped in. I don't know if she's on the phone, but I point out that we just spoke about your book a moment ago, and I don't know, Chris, are you able to unmute yourself, or if I add you as a speaker? Oh, I don't know if she is, but I was going to say one thing. We were hoping that. Oh, okay. Hi, Chris. How you doing?
Hi.
Can you hear me?
I'm on now.
Oh,
Great.
okay. Yeah, we were talking about I don't going back to you mentioned a story, Laura, about in Chris's book. What was the name? Swamp, was it called Swamp Boy?
Swamp Boy? Yeah, that was a great story.
Yes.
So Chris, what I was going to actually ask you is I think Dana had asked you if you would do at some point, if you would just do a Twitter space with us where we could talk about your book and your expertise in that area. That's kind of, I didn't mean to invite you in front of this space, but
talk about pressure.
No pressure or anything. But I appreciate you joined our space a couple weeks ago, and we'd love to just do one, with you talking about your book, if you're up for it at some point. No pressure, but
yeah, I mean, I just did a talk today with pandata.org, and the topic of the talk was the cover-up playbook for Lyme disease, what happened to Lyme disease, and how that applies to what happened with COVID, as far as also the deregulation of scientific research happened in 1980 with the Bayh-Dole Act, which allowed researchers and the CDC and the NIH to become business partners with pharma. And I think that corrupted objective science in a lot of fields. So it was the first time I took my book and everything that happened after the book and sort of consolidated it into a 30-minute presentation. And I think there are a lot of lessons takeaways that can be applied to COVID and whatever happens next.
So Chris, that's fascinating. Well, actually, that Bayh-Dole Act, okay, that's a whole other subject as well, because I think that's one of those examples of good intentions potentially run amok. Like but we can discuss that. So I guess the point is that it sounds like you have a 30-minute presentation that you would be able to do at our next Twitter space, right?
Yeah, and I think that sounds really important, this Bayh-Dole Act that should get aired.
I've always thought that was a good thing. I mean, as a researcher myself, it sounded like equitable that and I think for the listeners, the Bayh-Dole Act, that, to summarize it quickly, I believe that allows researchers to share in the financial rewards of the research that's funded by the government, right? Is that generally what the point of that was supposed to be?
Yeah,
Or like at the universities as well?
It was for government-funded research to get a payback for the investments they made. And it was good on the surface, but then there was, like many things, unintended consequences. And when you look at Lyme disease, which was the first new pathogen discovered after that law was passed, it's for a really dangerous pathogen, it slowed down the research because all of a sudden discoveries became intellectual property that had to be kept secret.
That's right.
And so it really slowed down. It slowed down science. It slowed down publications. Oh, we don't want to leak what we know about this pathogen because we're making a vaccine or a test kit for it.
But okay, yeah, that would be great to have that conversation, because I think, unfortunately, it's one of those things where you put in a regulation or a law that you think will benefit people, and eventually, ultimately it turns in this case, to be a horrific decision that has impacted many people's lives in a negative way. So,
Yeah, and then the other dimension of the talk I gave was the disinformation machine that cranks into gear when there's something
right.
that the government doesn't want you to know about. So I just gave one instance of what happened when my book came out and the ripple effect of that.
Well, yeah, and that, of course, we are very familiar with disinformation, although I suspect that there isn't anything as kind of I don't know if the word stupid or dumb as the raccoon dog thing. Is there a comparable thing to raccoon dog in the Lyme field, or is that like a low bar for kind of ridiculous misinformation, like very
Well,
low?
in my slideshow today, I thought about just putting one slide that said "raccoon dog" with 2 exclamation points.
I
So
think,
that I have 4 points on the disinformation playbook, and one of them is deflection. So if journalists or scientists are getting too close to the truth, they create some absurd shiny thing off to the side. So you forget that you were drilling down in this really hard secret thing on the left and go after the shiny raccoon dog.
yeah. Well,
So
that,
yeah, in Lyme disease, there is the equivalent.
I guess so. Thanks, Chris, for popping in, and I guess I'd look forward to scheduling a time where we could talk about those issues. Frankly, especially like that issue with the, what is it, the Bayh-Dole Act?
The
Yeah,
Bayh-Dole Act, yeah.
yeah. As a
But
scientist,
that
yeah.
was what I covered in my first documentary on Lyme disease, Under Our Skin, and just I followed the money, and it was shocking. It was something I didn't really realize was going on.
Well, it's when there's money, there's problems, I guess. Yeah. Although, yeah. Anyway, I guess we'll leave it with that. So I just want to say thanks again to Laura for going through her history with the One Health initiative and sort of where we can go from here to try to get back to the sort of noble ideology of One Health and take it away from, I don't know if we want to call them sort of charlatans or grifters or whatever, that are just exploiting a noble concept for ill means.
Thanks, Bryce. I appreciate.
Yeah, thank you, Laura.
Appreciate the opportunity to just share this information with everyone.